Parametric curves can be simple or really complicated. They can be pretty, they could just be a mess, but the way you evaluate them is fairly straightforward and tedious. And I can explain it very quickly, and then you'll have to work for a while to get through it, but here's the idea. We have these equations, and these are in terms of a parameter t. We're going to evaluate these equations for various values of t along this interval, -3 through +3. And for each one of those values of t, I'm going to plug it in and figure out what x and y are. So, as an example, t equals -3. Let's plug that in, see what we get. So x equals, from our equation, 2 times t. So that's 2 times -3, which means -6. Great. And y equals, well, let's see, t squared. So that's -3 squared minus 2. Okay, now that's going to be 9 minus 2, and that's just equal to 7. So the question would be, well, which one of these curves has this point? Okay, this is what I'm looking for. X equals -6, y equals 7. Okay, now I'm not sure which one of these curves has it. I can't be positive. I mean, I don't think it's these things. I think those would be a bad idea. I think it's probably these things, but I'm not sure because there's no tick marks on these graphs. So let's just hold that thought and plug the numbers in here and just start working through this. So we get -6 and 7. And you can go through here one at a time. I think it's quicker, personally, to plug in all the x values first because you'll see a pattern form really quickly, right? 2 times -2 is -4. 2 times -1 is -2. 0, 2, 4, 6. Okay, so all my x values were very quick. The y values, not quite so quick, but it shouldn't be too bad. -2 squared is 4. -2 is 2. -1 squared is 1. -2 is -1. Then I get -2, and then I'm back to -1, 2, and 7 again. Okay, so now I have all the x and y values. The question is, which one of these corresponds to my graph? Well, here's the way I would think about it. What is the direction of x and y, right? X is going positive, and y, it's not quite so simple with y. Y goes from positive to negative, back to positive. So match these things up to the curves. I think you'll find that 2 of these curves are very good candidates. Okay, these 2 right here. But which one is it? Well, you have to proceed through this table in order from t equals -3 to t equals +3. So we're going to start out here at x equals -6, y equals 7. We're going to proceed through these various points, say x equals 0, y equals -2, and we'll end up back here at x equals 6, y equals 7. Okay, you have to follow these things in order, and notice the direction of the arrow on here. Let me see if I can erase that. This arrow corresponds to the orientation of the curve. So it's not like we classify orientation into different categories like left orientation, right orientation, or that sort of thing. We just refer to the starting point and the ending point of this curve as having an orientation as in a direction. Okay, so that's what we mean mathematically by this thing. So it's not just enough to fill in this table. That's important, but you also have to pay attention to what the order is as you march through the parameter t in that table. The direction matters.